All right. So we solved systems graphically yesterday, and we just went over one of the homework problems. And like I said, it's not the most accurate way to solve for x and y. All right. Sometimes it works out great, but sometimes you want to do it algebraically. All right. That means do it with some math. All right. And there's two ways. They don't really make a big deal about this in this book. Maybe they just assume that you already know these two words, but I'm kind of surprised. Usually, if this was an algebra, substitution and elimination, those are the two words that they usually use. They make a big deal about it, but they kind of hide it like in the description somewhere. Usually it's like a big title, solve by substitution and solve by elimination. So let's write those two words down, and we are going to do it both ways. Now, there are some books that make you solve for certain things by substitution, and then another set of problems, you have to solve them by elimination. And they kind of force you to learn both methods, all right, substitution and elimination. But what we're going to do is we're just going to look at it, and we're going to decide what is the best method to use. Sometimes substitution is right there for you, okay? It just makes perfect sense to use substitution. Sometimes you look at it, you're like, oh man, if I use substitution on this, it's going to be really ugly. So there's got to be a better way. And elimination is usually that other way, that better way to do it. Do you remember this stuff from Algebra 1, at least the words? Okay. All right. So what we're going to do is start off right with an example. They don't give you really any lead in at all. And again, I think that's because this is Algebra 2, and substitution and elimination for the first time is really an Algebra 1 topic. All right. So I think that's kind of how they're treating it here. Yeah, it's been a couple years. Well, 2 years. Did we do anything in geometry with this? It seems like sometimes I do. I don't know. All right, let's do it. So 3x plus y equals negative 20. And then y equals. Now this is tailor-made for you to use substitution. A lot of books will do this. They put that little brace around it to show that they go together, which means what? They're not just two random equations. These two go together. It's a system of equations. Do you see that word systems? They call it a system because they go together. That means whatever this x is what? The same thing. It's the same exact thing. Same thing with the y's. Whatever this y is going to be, this y is the same exact number. So I want to find an x and a y that works for both of them. That's what I'm trying to do. All right? And like we just did earlier, we could graph it, find the point of intersection, and that's the point that's in common with both of them. But we're going to do it algebraically instead of graphically. This is perfect for substitution. They give you the easiest problem. Because what are we going to substitute in? We're going to substitute something in for another letter. So they kind of already tell you what y is equal to, don't they? They tell you that y is what? X minus 8. Now remember what we said about both of these things. Both of these y's are the same thing, right? Both of these x's are the same thing. So if y down here equals x minus 8, what can we do right here? That's right. You can plug that x minus 8 in for that y. Everybody see that? So that's my what? Substitution. That's why they call it substitution, because your first step is to substitute. So what we're going to do is we're going to rewrite that first equation, but instead of 3x plus y, what are we going to write? 3x plus x minus 8. And then you finish it off, okay? So it's 3x plus the y, which is x minus 8, equals negative 20. Because all I did was rewrite that first equation, okay? But instead of writing it with a y in there, I put what y is equal to. And since they wrote y in terms of x, look what I have here. I got all x's, and now I can solve for it. Everybody see that? All right, let's do it. 3x plus 4x. Oh, gave it away. 3x plus 1x is 4x. Let's add the 8 to the other side. It's negative 12. All right, divide by 4. X is negative 3. Are we done? No, because we got to find what else. You got to find what y is. So we know x is equal to negative 3. Do not circle it just yet. I'm going to show you how to write the answer. We're going to write it just like we did when we did it graphically. How did we write those answers? As an ordered pair. Why do we write it as an ordered pair? Because it's a what? It's a point, right? It's a point on the graph. It's the point of intersection between these two lines. So I'll save that, right? We're going to write it as an ordered pair as soon as we find out what y is equal to. Now, what we can do, if I wanted to, I could put that negative 3 in for this x right here, couldn't I? Yeah, but this is just handed to you on a silver platter, right, to solve for y. They already got y equals something, so let's write y equals. And I could put it in, I could have put that x, that negative 3 in for this x, or I could put it in for this x. It doesn't matter, you'll get the same answer, all right? But this one's a little bit easier, so that's what I'm going to do. So x is what? Negative 3, so y equals negative 3 what? Minus 8, which is negative 11. So how do I write my answer? I write it as an ordered pair. What goes first? Negative 3 and then negative 11. So that is what I'm going to circle. That's my answer. So if you were to graph it, if you were to graph both of those equations, where would they intersect? At negative 3, negative 11, exactly. Make sense? Yeah, that's pretty easy. They started you off with a really easy one. This next one is almost just as easy. So this is example 2. And I'm going to put solve right here. Okay. Should have done that for the first one. Did I do that for the first one? Nope. I should have. Okay, because they got to tell you what to do, right? So they say solve. All right, let's write this one down. So it's 2x minus y equals 8. Uh-oh. Who's that? Dude.
I promise you I didn't touch my phone. Yes, you did, sir.
Well, maybe you should have touched it and turned it off. All right, here we go. So we're still going to do substitution, but watch. Everybody look. Come on. We still are going to do substitution, but on the other one, like I said, it was handed to you, wasn't it? On a silver platter. They told you y equals something, all right? In this case, they don't tell you exactly y equals something, but we can do one little tiny step to get y by itself. Which one would you get by itself? And it doesn't even have to be the y. Okay, I would get that y right there by itself. That's the easiest one. Is that the only one that you could get by itself? No. I could have solved for this x. I could have solved for this y. But that would look really ugly. It would work, okay? It would work, but it's going to take too much effort. All right, do the easiest. This is terrible because a lot of adults say, oh, don't do things as easy as you can. Yeah, in this case, yeah, use the easiest method that you can. All right, so let's do this. I could do this in my head, couldn't you? I'm going to add a y, put it over here, and then get rid of the 8. So I subtract an 8. So what's y equal then? 2x what? Minus 8. Okay, so that shouldn't be a big deal. So now what are we going to do? Now we're going to do exactly what we did on the last one. So now we're going to take this y right there and we're going to put it in to the other equation. Don't put it back into itself because everything will cancel out. All right, don't do that. Put it into the other equation. Everybody see that? So I've got 4x plus 3. What is that 3 doing to that y? Multiplying, so I put a parenthesis there because I'm multiplying by two things. So it's 2x minus 8. And then finish off the rest of the equation. There's the 4x, there's the 3y, equals what? Equals 2. And now we just do some basic math and solve for x. So let's do that. 4x plus distribute, 6x minus 24 equals 2. Add like terms, 10x. Let's add the 24 to both sides. 10x equals 26. Divide by 10. So x is, let's simplify the fraction. What goes into 26 and 10? They're even numbers. 2. Right, 2 goes into both of those, right? And so what is that? 13 over what? 5. So that's my x. Not the prettiest answer, but that's okay. All right, it happens in life, okay? You rarely, if you do engineering and stuff like that, you never come out with well, I wouldn't say never, but very rarely come out to nice whole numbers or integer numbers, okay? Most of the time you come out with decimals and things like that. That's the way life is, all right? So it's not that big of a deal if we get a fraction. Now we got to solve for y again. Now, I could take that x, I could put it in right here, and work it out, or where would you use it? I already got y by itself right here, don't I? So that's what I would do. I think that's the easiest way to do it. But you could put it in anywhere you see an x. You could put 13 over 5 and then solve for y. All right, but this one's definitely the easiest one to use, so let's use it. So y equals 2 times x. I'm going to put 2 over 1. Why in the world would I put 2 over 1? Because I'm multiplying it by a what? A fraction. Okay, there's my 2x right there. Y equals 2x, and then minus 8. Let's just do it right now. What am I going to do with these two? I'm going to multiply them, correct? What's my common denominator? Or what is my denominator? I'm sorry. It's just 5. So instead of writing 8 over 1, let's just get it over with right now. Let's make the denominator 5, and what would our numerator be? 40. Right, because 40 over 5 is 8. Everybody with me? So y equals, let's do the multiplication, 2 times 13, that's 26 over 5 minus what? 40 over 5. And that gives you 26 minus 40 is what? Negative 14, is that right? Yep, negative 14 over 5. It can't be reduced, so we just keep it like that. There's really no reason right now to change it to a mixed number. If we had to graph it, then absolutely turn it into a mixed number. But you don't have to graph it on these problems, so I would just keep it improper. It's perfectly fine. In fact, that's the way that they would read off the answer. So what's my final answer now? It's 13 fifths, comma, negative 14 fifths. And that's where they're going to intersect. Now, what if you did this? What if I asked you to solve this graphically using graph paper? Do you think there's any way in the world that you would look at that point and say, oh, that's what? What is that, 2 3/5? Is there any way? No, there's no way I would be able to look at it and say that's 2 3/5 if I graphed it, okay? So that's why solving it algebraically sometimes most of the time, is a whole lot better. Everybody good with that? Yeah, because you'd have to be so specific. I mean, there's just no way you would guess that. All right, let's do another one. This time, I'm going to show you the elimination method. It doesn't tell you that you have to do it by elimination. You could do this by substitution, and it probably would be almost just as easy. All right, example 3. And it says to solve. And here it is. But this one is kind of set up for you to use elimination. All right, there we go. And again, this book doesn't do it, but a lot of books put a little brace right there just to show you that they go together. All right, you don't have to have it, but that's what they do. All right, so what we're going to do is this. I'm not going to explain it, I'm just going to tell you. Okay, if you have two equations like this, what you can do is you could add those equations together. But right now, if I just add them the way they are, you're not really going to accomplish anything. All right, but what I want to try to do, it'd be nice if I had like a positive variable on the top and the same exact variable on the bottom, but it's a minus. Okay, now I could just subtract them from each other as well. Some teachers will teach that, okay? Subtract the two equations from each other. But I like to do add. So sometimes if I said subtract, sometimes you forget about the negative, right? You forget about that. So what I would do is I would change one of them to a negative and then add them together. So I got two of the same exact things here. I got a plus 1y and a plus 1y. So I'm going to change one of them to a negative. Doesn't matter which one you pick. All right, let's pick the bottom one. So what I'm going to do is multiply everything on the bottom by a negative, or a negative 1, all right, technically. So negative 1 here, and then negative 2 right there. Now I'm allowed to do that. Why am I allowed to do that? Because whatever I do to one side, I can do to the other side, all right? So I'm allowed to do that. It's perfectly fine. Everybody okay with that? All right, what I'm going to do is just rewrite this again, but I'm going to write it with the negatives here. All right, just rewrote the top, didn't change the top at all, but the bottom changes a little bit, doesn't it? What's it become? Negative 2x, what? minus y equals negative 2. Now, in elimination, what I'm allowed to do is I'm allowed to add up all the columns. I'm allowed to add up the x's and the y's, and I'm allowed to add up the constants on the end, okay? So let's do that. This is positive 1, so what's 1x minus x, or 2x? What's 1 minus 2? Anybody here? 1 minus 2. 1 minus 2. It's negative 1x. Oh, my word. I hope you're just messing around with me. Just didn't want to answer me. Okay. What happens here, though? Look, pause. Shh, turn around. Focus. So positive y, negative y. What happens there? Yeah, they add up to 0, right? Or we say they cancel out. All right, equals, what's that? Negative 1 minus 2? It's negative 3. Divide everything or multiply everything by negative 1. What's x? X equals 3. All right, we'll hang on that for a second. Let's solve for y. Now, again, I can use either this equation, this one, or this one, the original one. Doesn't matter which one I use, right? Anything with a y in it. What would you use? I would probably use that first one, absolutely. Okay, so let's do it. So x plus y equals negative 1. Let's put the x in for that. That's 3 plus y equals negative 1. Subtract 3 from both sides. What's y? It's negative 4. How do I write my final answer? 3, negative 4. All right, pretty easy. That elimination was pretty easy. All we had to do is look to see if we have the same exact variables. All right, if they're both positive, I'm going to make the other one negative. All right, as easy as that. I could also, if I wanted to, I could have eliminated the x's in my first step. I didn't have to eliminate the y's. It was just the easiest way to do it. Okay, if I wanted to, I could eliminate the x's. What could I have done to eliminate the x's? I want them to be exactly the same, except one's positive, one's negative. So I could have done what? Multiply that by 2. And if I multiply that by 2, I got to multiply everything by 2. So I could have eliminated the x's, got y first, then plugged it back in. So really, the first step was elimination. The second step was back to substitution again, wasn't it? So really, it was only the first step where we did elimination right there. Okay? All right, let's do another one. This one's a little tougher. Is this coming back to you from algebra? Algebra 1? Yeah. Do you think you'd be able to do this on your own before you walked into this class?
Yeah.
Okay, so right off the bat, even without me even go over this?
No.
Yeah.
Even if it says solve by substitution, can we do elimination?
Does it say do it by substitution?
Yeah, for number 7 through 10, it says solve by substitution.
No, let's do it the way they want you to do it. I mean, I'm not going to go through the homework, and if you didn't do it by substitution, I'm not going to mark it wrong or give you points off or anything like that. But they're doing that for a reason. Okay? They want you to practice using substitution, and they want you to practice using elimination. So I think it's good to do it the way. Now, on a test or a quiz, I will not tell you you have to do it by substitution or you have to do it by elimination. Okay? Whatever way that you want to do it. The only way that I'm going to tell you to solve would be which way? Solve by graphing, right? Okay, that's really the only way that I'll tell you where you have to solve it. But on these, it doesn't matter. All right, look at this one. This was not quite as friendly as the other one was. Are you going to use substitution, first of all? Do you have like an x or a y where I could get it by itself really easy? No, I don't, okay? They all have coefficients in front of them, right? You know what a coefficient is? That number in front of the variable. All right, they all have these coefficients other than 1. So it makes it a little tough. So I would definitely choose elimination on this. And I can almost guarantee, they would not give you this and say solve by substitution. All right? I can almost guarantee they wouldn't ask you to do that. All right? I would not give that to you. Remember, I said on a quiz or a test, I am not going to tell you. You could solve this by elimination, sure. All right? But it would be too much work. Okay? It'd be too, I don't know, too much. So what we're going to do is we're going to do elimination. So we have to decide which ones are we going to eliminate. Now, you could eliminate the x's, or you could eliminate the y's. It doesn't make any difference. Zanai, what'd you say? Why would you eliminate the y's? Okay, and not just by a 3, because they're both positive. Yeah, I would multiply it by a -3. Everybody see that? And you only have to do 1. I could eliminate the x's, but what would I have to do if I wanted to eliminate the x's? What do I want them to come out to be? Well, okay, I didn't word that question very well. What would I want to turn the x's into for them to eliminate? That's a better way to say it. Numbers. Give me numbers. What number do I want the x's to come out to be so I can add them up to 0? Give me numbers. Give me a number. I want a number. What? I can turn that into a 2? Come on. Thank you. Turn this into a 35. All right? Because look, I got 5 and 7. What's the smallest number that 5 and 7 divide evenly into? 35. So I can make this a 35 and then make this one a what? A -35. Okay, so I could do that if I wanted to. But I would have to multiply this by a 5, and I'd have to multiply that by a -7. That's 2 things that I have to do. Right here, all I'd have to do is multiply this 2 by a what? For these to eliminate, a -3. So I only have to do something to one of these equations. So that's the easiest way to do it. So I'm going to multiply this whole thing by a -3 and multiply that whole thing by a -3. All right, so let's rewrite it. I'm just going to copy and paste that one. Saves me writing it. And then I'm going to go ahead and multiply everything by -3 there. So what does that give me here? -15x minus what? 6y equals -3. Now, look. Now we made this so that we could eliminate the y's, didn't we? All right, so let's do that. So I'm going to add up all my columns. So if I add those 2 up, they're going to eliminate. What do I get when I get this? 7x minus 15x. That's -8x. And this is going to be -7. Divide by -8. So x is 7/8. Again, doesn't come out super pretty, but that's okay. We can deal with it. Now, I'm going to show you what they do in the book. If it was me, I probably wouldn't do it. I would probably, and I understand why they do it this way, because they're kind of getting you away from the fractions, right? If you don't like fractions, this next step is probably what you want to do. But here's what I would do. I would take either one of these equations, it doesn't make any difference, either one of these, and take that 7/8 and put it in for the x. All right? So if I multiply that by 7/8, I'm going to get some fraction, and then I'm really going to have to deal with fractions, find common denominators. Really, it's not that big of a deal. It shouldn't be anyway. At your level, dealing with fractions shouldn't be a big deal. But I know from many, many years of teaching that people don't like using fractions. So here's what the book does. Everybody watching? I am going to do this. Since I can just erase these, I will. What they're going to do, they're going to eliminate the x's, and we talked about it earlier, right? They're going to eliminate the x's and be left with the y's. So you don't actually have to take this and plug it in to one of the other x's. Everybody see that? Because it can be a pain in the butt. Put a 7/8 in for this. 7 times 7/8 is 49/8. Then you got to subtract a 49/8. Then you got to make that a common denominator. Then you got to divide by a 6. Do you see the issue with that? Yeah, that could be an issue. It will work. It's fine, but it's kind of ugly. So let's try to make it as easy as possible. So I'm going to go to a different color this time. All right, so what we can do is now eliminate the x's. We already talked about that. What would I have to do? Multiply this by 5. And then what would I multiply this by? A -7, correct. Whoops. Okay. It looks like this might be more time-consuming or a little bit tougher. I think this might be a little bit easier, though, than taking this and plugging it into x. You can try it, all right, and compare. But this is what we're going to do. So let's rewrite the top. What do I get? I get 35x plus 30y equals negative 20. The bottom one, I get a negative 35x. That's why I did that. Everybody see it? That's why I did it. So these will eliminate. And this is negative 14y, and this is negative 7. So now I'm ready to add up all the columns. So if I add those two up, they'll eliminate. They'll go away. Add up to 0. All right, cancel out, whatever you want to call this. So what will this be? 16y equals negative 27. Divide both sides by 16. You barely had to even do anything with fractions at all, did you? You see that? So you didn't even have to worry about finding common denominators and all that kind of stuff. I think you would agree that doing it that way was probably a little easier than taking a fraction, right, and plugging it back in. Would you agree? All right, my final answer obviously is, hopefully it's obvious, 7/8 negative 27 over 16. And that's the answer. You okay with that? When's this over? 5 after? I don't know if I have enough time to do the next one. But yeah, it's a little different because they say you're big kids. What? You're big kids, so read and I don't know, try example 5 on your own. No. Okay? But that's a little extra. Okay? So do that. Actually, what you're going to do for homework, I split it up into A and B, and I don't think you have this thing to do on A anyway. All right? So what they're asking for example 5, I don't think you have to do for A and B. I did split it up, didn't I, on the lesson plan? Okay, so we're going to call this, so maybe I'll go over this tomorrow, or not tomorrow, but Thursday, okay? So here's your homework, 3.2a, and it's page 115. This is on the lesson plan, but I'll write it down anyway, 7 to 14. I really don't think they give you any like example 5 on 7 to 14. Yeah, I don't have the book out in front of me, but if they ask you to do it by substitution, do it by substitution. If they ask you to do it by elimination, then do it that way, okay? There's reasons for that, okay? Because they want you to practice doing it both ways. Don't just get used to doing it one way. Just don't get used to always doing it by elimination every single time, because sometimes substitution's a lot easier, all right? All right. Everybody good? Yeah. All right. So that's due on Thursday. So have those finished by Thursday.